Okay, so in this lesson, we'll like to talk about the basic properties of the fire and smoke while we're going to construct the fluid containers. Okay, so let's get started with that. So first, we'll like to create the smoke and the fire containers. We need to go inside the FX menu and we need to create the fluids, the 3D containers, all right? And if I'm gonna reset the properties, we do have added the basic emitter attributes. That means the default emitter is also going to get attached with the fluid, so we don't need that because in our case the tree in itself will going to be the emitter for our fluids. So first of all, create, apply and close, and let's just bring it a little bit upwards. And the first thing will going to be, we have to manage very intelligently and legitimately the entire fluid container with respect to the size of our tree, because it's very important, because we also going to have a lot of database of the fluids with respect to the you can say the base resolutions. I think so I'm going to utilize approximately 300, which is fairly a very high value to calculate. All right, so what we're going to do here is that we'll just start blocking out the size of our fluid containers. So let's say we're going to go inside first the x axis of the fluid container, which is the x side. Let's say we're gonna have the 15 value for this. All right, and so with that we do have the sufficient space for our model to get inside. Okay, now for the y, it's absolutely important because we don't want the fluid to rise way too much high with respect to the overall height of the fluid once we'll start calculating the simulations of the fluid. So you may could change it according to your own artistic decision, but as I have practiced and noticed some behavior and the values, according to me the value of 16 or maybe 17 would be the best to minimize the computational steps of the fluids, as well as the other things like the like in such a high base resolution, it's always recommended to use these values very carefully. Okay, so the x and the y section is done. Now we're going to talk about the z. So let's also put that thing to the 15. Now as you can start it figuring out, the tree is now inside the fluid container. All right, however, we also know the fact that not the entire section of the tree will going to emit the fire, or this entire tree will not going to be put upon the fire. So what we're going to do is that we'll use only the half section of the tree. So what we can do is that we can still utilize a little bit the z section of our fluid, but not too much. We need to be very, very careful in that. Okay, so this area will particular area will going to be, you can say, the area where the fluid will start moving. Okay, so that means it's the z negative axis where the fields and the winds will also going to affect the fluids, and they will also going to push the fluid towards the z negative directions. All right, and if this is done and we have already understood this concept, let me just first of all name my container, which is the tree underscore fire fluid. All right, that's cool. And if I'm going to open up with the outliner, you can see that there is only 1, 2, 3, and 4 informations inside our scene. And we also do have the light group where I've kept all the lights inside this group, so we don't need to bother about these lights. We have the sky dome, we have the BG plane, we have the tree mesh, and there is another thing that is called the camera, because according to my aesthetic, you can say my own aesthetic decision, I have taken this camera with respect to that you can say positions in certain directions. This suits to me with the best. All right, now let's come back to the perspective view again. Okay, so let's just do one more thing. Let's just start blocking out quickly the other elements. First of all, inside the fluid containers, in this case we're not going to utilize the auto resize function of the fluid. Many of you must be knowing regarding the auto resize. It is basically the feature of the Maya fluids that allows to quickly expand and contract the container of the fluid with respect to the fluids that are only moving around the emitters, if we're going to utilize this auto resize. But as if for now we're not going to utilize that. So what we're going to do here is that we'll set the boundary x to the both, and this boundary will not going to get any expand or any contract. In fact, the case is that all these sections will going to get closed. There will not going to be any boundary or any XYZ axis to be kept open for the auto resize utilizations. Alright, so this section must be clear to all of you. We're not going to utilize any of these things. Well, the simple reason is that since the fluid will going to move in this particular directions, and the only problem is that based upon the values which we're going to give in our container, the fluid might tend to expand, or you can say enhance the size of the fluid container. That would end up in a lot of computational steps, as well as a lot of RAM and the, you can say, unwanted space inside the hard disk with respect to the cache sizes, because the length of the fire of the tree will not going to be too high. But if we kept these things to be you can say both the sides, or say none, boundary set to be none, then what will gonna be the problem? The problem will be that the fluid will keep on rising, the size of the container will keep on rising, and that would be, you can say, the unnecessary calculation. So this is the reason why I do not want to initiate the boundary contraction and expansions. All right, so let's just do one thing. We'll move further down towards the content methods. Here we do have the density, velocity, and the temperature. We're also going to set that thing to the dynamic grid, and we're not going to utilize the fuel in this case. All right, moving further to the display attribute, we'll like to take the boundary draw to the bounding box. Okay, and moving towards the dynamic simulations, we do have the gravity, of course. We're not going to utilize the viscosity and the frictions. We're going to give some dam, which is the technical value which affects per frame the speed of the fluids. Alright, so you can say that if the solution is set to the 1, the fluid will not tend to move in an upward directions. Alright, so this will also going to affect the velocity of the fluids per frames. The solver will remain the Navier-Stokes, and the high detail solve will set to the all grids. Alright, and for the sub-steps, we would like to take to the 2, since the speed and, you can say, the behavior of the fire will going to be very agile and very, you can say, aggressive. So we would like to take 2 calculations inside our fluid containers. Okay, and the solver quality. Now this particular section is very important to calculate the crispiness inside the fire. I request you to pay attention over here. The solver attribute is very important to decide whether you would like to give the crispiness inside your fluids, or whether you would like to give some bulginess inside your fluids. See, according to my experience, if you give a very high value of the solver quality, the fluid tend to give you the impact in a very crispy manner. Since our reaction particularly required the fluid to be really very crispy, the fire is really required to be crispy, so I would like to take down the values to 150. You may also could take them to the 200 as well. Alright, so it just completely depends up to you, but I recommend these are the minimal settings from which everybody can take the advantage of the course based upon the minimal system requirements. Okay, solver quality 150 should be the ideal value to get started. Now moving towards the simulation rate scale, which will going to decide the overall speed of the fluid. So here in this case, I would like to take down to 2.5. Okay, because the fire will really going to be a little bit higher and, you can say, aggressive, so we can't have the simulation rate scale 1, so that will not going to add any aesthetic sense to the scene. And moving towards down, we do have the emitter substeps. Since we are utilizing the substeps too, we are required to switch on this attributes. All right, Moving down towards the auto resize, I've already discussed with you, we're not going to utilize the auto resize. And in the later section also, I'll also going to describe some more regarding the auto resize, that why exactly we are not utilizing the auto resize functions. Okay, so at least for now, let's put the auto resize function to off. Okay, so with that, we are good to create the basic blocking of our fluid container. Now let's move to the next section where we like to define the density parameters and the velocity parameters of our fluid. All right, so see you in the next section.